So this section is going to talk about reactions or activity with acids on metals. So if you've never tried it before, acids do react with most metals. And in the case of whether it's going to react with something, these are the majority of the metals that it will react with. So there is a table in your reference table. It is table J. So what this means is that you're going to take some kind of acid, okay? Doesn't matter what it is. But once you add it to some type of metal, there's going to be a reaction. And that reaction usually gives off a hydrogen gas, and it creates some kind of salt, meaning that the metal is no longer its metal, but it's something slightly different. And we can see this when we look at iron. Let's say you have some tools, you left them outside, there are a couple of nicks in them, it rained. Ultimately, if you leave it out there for long periods of time, it's going to have this oxidation on it. It's going to have this rust. That rust is actually iron oxide, which is a salt by definition. Okay. Since the reaction is not with a very, very reactive acid, you're not going to see bubbles. Okay, so you're going to leave your hammer outside, you're not going to be seeing bubbles. However, if you have some kind of metal, let's say, on the top of this list, like lithium or rubidium, those are your most active, meaning that you put an acid on those, there's going to be some kind of violent reactivity. And we can see this because these are usually the metals on the left-hand side of your periodic table. Okay, so any metal, really, that is above this line, which is our standard line, something to compare it to, because we need to know, well, what's going to be the most active metal? I would not want to be putting lithium into, say, like my car. That would be a metal that I would not make my car out of because it's very reactive. So if there's going to be, say, acid rain or something, it's not going to last. So we say that any metal that's above that H2 gas line is going to react to an acid. It's going to react, again, to produce this stuff. Okay, so it's going to be producing, let me just move this out of the way, or I'll just leave it there. Any metal that's below is not going to react with an acid. We call these our kind of our coinage metals, meaning copper, gold, silver. We use this, actually, acids and bases to clean these metals. There's minimal reactivity, which is good because if I clean my engagement ring or my wedding ring, I don't want it to be evaporating over time. So that's what makes gold, silver, and copper pretty non-reactive with most acids. Okay, so there's only three that you really have to know that are not reactive, and we call those our coin metals. So let's take a look at how we would use this in the real assessment part. Zinc, a solid, most metals are solids, are being reacted with some type of acid. So what's going to happen is we are going to take the H, okay, and that H is going to be used as our gas, and the metal is going to match up with its nonmetal. So this is how we would write that. So we're going to have H2 gas, and we know that hydrogen is diatomic, and it's going to have a salt, which is a metal and a nonmetal. This is going to be a gas, and this is actually going to be an aqueous solution. Okay. Now, how do we know that that would actually happen? Let's take a look at where zinc is in this activity series. Just erase this so it looks a little bit better. Okay. Zinc is found here. So because it is over this standard line, it's going to react with an acid. Let's take a look at the second one. This one is going to be right here, silver. Because it's below the H2, there's nothing that's going to happen. So this is no reaction. Again, it has to be above that hydrogen mark. Now let's take a look at calcium. Calcium appears to be right there, which is definitely more reactive than zinc would be. So what we do is we're going to take that calcium, we're going to stick it with the salt there, and that's going to create...
Are you on another Zoom meeting?
It's going to create a salt and, of course, hydrogen gas. Okay. So when metals react with acids, this is an example of a single replacement reaction, okay? Because as we can see, the metal gets together with the other part, so this is considered a single reaction.